So January 2017, Unit 2. So which of the reaction is a disproportionation reaction? If the same element is oxidized or reduced, these are known as a disproportionation reaction. So how we can identify? We have to check the oxidation number for each, and using the oxidation number we can identify which one is oxidized or reduced. Here chlorine is 0, potassium plus 1, bromine minus 1, potassium plus 1, chlorine minus 1, and bromine 0. So here chlorine is reduced and bromine is oxidized, so this is a simple redox reaction. But in a disproportionation reaction, the same element should be oxidized and reduced. Chlorine plus sodium, so oxidation numbers are 0, sodium is plus 1, chlorine minus 1. So this will become plus 1, oxidation, reduction. So it is also a redox reaction. Element state, the oxidation numbers are 0, so phosphorus and chlorine both have oxidation number 0. But in case of phosphorus pentachloride, each chlorine is minus 1. So this will be minus 3, this will be plus 3. And this is minus 5, so this will be plus 5. So both the products, the phosphorus is oxidized because 0 become plus 3 or 0 become plus 5. And both the products, the chlorine is reduced. But when we check the last one, chlorine is 0 here. Here in sodium chloride, chlorine is minus 1. So this is reduction. And in sodium chlorate, NaClO, each oxygen is minus 2, sodium is plus 1. So chlorine should also be plus 1. Overall compound is neutral. So chlorine from 0 become plus 1. So one side it is reduced, another one oxidized. So when same element oxidize or reduce, we call that as disproportionation reaction. So that's why D is the right answer. In which of the following would you expect the paired species to have different bond angle? So we have to check the geometry of each of the molecule. So in case of H2O, how many bond pairs are there in H2O? There will be, if they have the same number of bond and lone pair, then they will have the same geometry. So 2 bond pair, 2 lone pair means it will be bench structure. In NH2 with a charge of minus, so what does it mean? Like nitrogen bonded with 2 hydrogen, and there will be unshared 3 because nitrogen belongs to group 5, share 3, unshared will be 2. So one extra it does not form and it took extra electron, so that minus charge, so it took extra electron, and because of the presence of that extra electron, now it become 2 bond pair and 2 lone pair, so both will have the same geometry. Because if the geometry of the molecule depends on number of the bond pair and lone pairs, if the molecules have the same bond and lone pair, then they will have the same geometries. So A cannot be, it will have same. When we check NH4, nitrogen loses, so nitrogen will have 4 electrons because the charge is plus 1, so it loses 4 electron, and then 4 it shares, so tetrahedral because 4 bond pair. And in CH4, 4 bond pair and there is no lone pair, so it will be tetrahedral. So both will have the same geometry. When we check BF3, boron tetrafluoride, so boron does not have any lone pair, only 3 bond pairs. But in case of NH3, 3 bond pairs and 1 lone pair. So when there are 3 bond pairs and 1 lone pair, this will be trigonal planar, and this is pyramidal. So they will have the different geometry. As a result, the two molecules will have the different bond angle. Here the bond angle will be 120, but because of four bond pairs are there, the bond angle is 109.5. But due to the presence of one lone pair, the bond angle decreases by 2.5, so the bond angle will be 107. So they will have a different bond angle. So how to identify this? The simple way to identify is check the number of the bond pair and the number of lone pairs. Then in question 3, the global warming is an environmental concern result from a greenhouse gases trapping radiation from the earth. Identify the type of radiation involved and its effect. So which type of radiation are involved? The infrared radiation or IR radiations are there, and what it cause? It not cause a bond breaking, vibration, because like example, when bonds are polar, these polar bonds have a tendency to absorb IR radiation and the bond will vibrate, or you can also say stretch or bend. So B is the right answer. Ultraviolet UV is causing a bond breaking, or you can also say bond fission, but it does not leads to a global warming. Global warming is because of the infrared radiation, and that is due to vibration of the bonds. Ozone layer is depleted by series of reaction involved trichlorofluoromethane CFCl3. Some of the possible reactions are shown. Which is an initiation reaction? Initiation, how to identify initiation? When it produces free radicals are produced, that is how the reaction started. Like when the product is free radicals. So which one involve free radical? You can see the reaction to involve free radical. Both products are free radical. That's why we call initiation. Propagation in the reaction shown, what best describe the role of a chlorine free radical in depletion of ozone? So look, it started with a chlorine free radical, like it produces chlorine free radical. Chlorine free radical reacted with ozone, from chlorate radical ClO radical reacted with oxygen, form again chlorine radical. So means chlorine is reproduced, or chlorine is given off, chlorine free radical is given off again. So it means it is chemically, it does not consume, or it is not consumed. So if chemically substance is not consumed and it helped the reaction to occur, so what we call that substance, we call that as a catalyst. So chlorine free radical is actually acting like a catalyst. Then which of the following is a possible termination reaction? In a termination reaction, what happens? Free radicals react to form a molecule. So free radicals react to form a molecule. So which equation involve a two free radicals and form a molecule? So C involve the two free radicals join and form a molecule. So C will be the right answer. So initiation is when free radicals are produced, where termination is when free radicals combine and form a molecule. At room temperature, iodine is solid and bromine is liquid. The best explanation for this. So it is about the intermolecular forces, both iodine and chlorine or bromine. They are diatomic molecule, and they have induced dipole forces. They don't have permanent dipoles. So at room temperature, iodine is solid, bromine is liquid. The best explanation, bromine has weak, it does not have permanent dipole. Bromine is more volatile, but that is it's volatile liquid, but it does not explain the idea. We want to explain why bromine is liquid. Iodine has a stronger covalent bond. Even bromine is also having a stronger covalent bond. The melting point or boiling point does not depend on type of the bond. Like basically it depends on intermolecular forces. So iodine has a strong London forces because there are more electrons, so strong London forces. That's why melting point of iodine is higher than bromine. And London dispersion forces increases as the number of electron increases. Which molecule have the highest boiling point? For a hydrocarbon, for a carbon compounds, the boiling point depends on number one. The boiling point is proportional to number of the carbon atoms, greater the number of carbon, and boiling point is inversely proportional to number of the branches. Few branches, higher boiling point, and more carbon, higher boiling point. So first we have to check the criteria to check is first check the number of the carbon and then the then the branches. So when you check the number of the carbon starting 1, 2, 3, 4, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Like here 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. So three of them B, C and D have 5. But when we check the branches, this is having like this is a straight chain, so two branches. This is a chain, so one branch, and this is a straight chain, does not have any branch. So no, when few branches or no branches, it will have large surface area, so it will have the higher boiling point. So the boiling point depends on the number of the carbon atoms present. Covalent bond length is defined as, so how we define the covalent bond length or length of the bond? The distance from a nucleus of one atom to outermost electron of the other. Like example, this is a nucleus. So this is a nucleus. Then we have, this is outer electron. This one is another outer electron and the second nucleus. So how the question is how we define the basically the covalent bond length is actually a distance between the two nuclei. That's called a covalent bond length. So, which statement explain distance from a nucleus of one atom to outer electron of other? Means they're saying this distance of a from nucleus to outer electron of other. So that is not a covalent bond length. That's wrong. Distance from a nucleus of one atom to the nucleus of other. That's true. Like starting from one nucleus to another, the length is known as the bond length. So B will be the right answer. In question 8, hydrogen peroxide decomposed forming water. Which chain does not increase the rate of the reaction? And this reaction can be catalyzed by like transition element like manganese oxide, even copper oxide can also catalyze this reaction. So which one does not increase the rate of reaction? Adding a powdered catalyst, manganese. So if you use a catalyst, it will increase the rate of reaction. Increasing a concentration of hydrogen peroxide, there will be more particles, so the rate will increase as well. Increasing a pressure, if we change the pressure, because here reactants are not in a gaseous state, so pressure only effect for a gaseous reactant. And increasing a temperature will also increases the rate. So C, that increasing a pressure from 2 atmosphere to 4 atmosphere will not change the speed or the rate of this reaction. In question 9, consider the following reactions. X2 plus 3y2 gives 2x by 3. Increasing a pressure increases the rate because, so why this is a reversible reaction, but we are increasing a pressure. Why it increases the rate of the reaction? Increases the molecular energy. Molecular energy only changes if we change the temperature. Shift the position of equilibrium towards the right. That is true, but that does not explain the rate of the reaction. That shows the yield, like the equilibrium shifted towards the right hand side, towards the side where number of moles of particle are less. So B is also not the right one, because B's statement is correct, but it does not explain the idea that why the rate increases. Increasing the collision frequency, that's true, because when we increase the pressure, the particles come closer to each other, they will collide often. As a result, it increases the, and activation energy can change only by using a catalyst. So if you use a catalyst lower the activation energy, so reaction can proceed at low energy. Question 10, which type of radiation is often used in pharmaceutical industry to heat the reaction mixture? So for heating purpose, which type of radiation is used? The first one is written gamma. Gamma is not for heating purpose, it is for radiotherapy. Microwaves As you can see, the microwaves or microwave oven, so that is the main purpose, because the particle absorb, they vibrate, so microwave is actually used to heat the mixture. Ultraviolet is used to break the bond, and X-rays are used to sterilize, to kill bacteria, or for identifying the leakage or the blockage, or to identify the cracks in the metal. So we use X-ray. So the correct answer is B, that microwaves are used in the pharmaceutical industry to heat the mixture, because microwave radiations absorbed by the molecules, they vibrate. The bond does not break, only the particles vibrate. Question 11. The potassium halide KCl, KBr, and Ki can all react with concentrated sulfuric acid to produce. Look, chloride ions are, what is the first reaction? Like if you have KCl, KBr, and Ki, the first thing what they will produce hydrogen halides. Like H, when it reacted with H2SO4, this also reacted with H2SO4, and this also reacted with H2SO4. So what it produce? This will produce potassium hydrogen sulfate plus HCl. This will produce potassium hydrogen sulfate plus HBr. And this will produce potassium, and the first reaction is acid base reaction, because acids are proton donors, bases are proton acceptors, so it donate proton, and that is transferred to KCl plus Hi. So first reaction is always to produce hydrogen halide, and this hydrogen halide which is produced further react with sulfuric acid, other molecule of sulfuric acid, to produce multiple products. But in case of HCl, chloride ions are not good reducing agent, so they are not reacting further. But bromide and iodide ion are good reducing agent, so this result in multiple products. So when the first reaction occur between potassium chloride, potassium bromide, or potassium iodide with sulfuric acid, the first product is hydrogen halide. So A is the right answer. The other products not produced by all of them, like hydrogen bromide, when it reacts, it produces bromine molecule, and it produces either sulfur metal or sulfur dioxide. Hydrogen iodide, because iodide is a good reducing agent, so it produces hydrogen sulfide gas, which is having a rotten egg smell. In question 12, the reaction between potassium halide and silver nitrate in a solution is, what is the ionic equation? So how to write an ionic equation? We cancel out the common ion in aqueous. So nitrate ion will cancel out, and potassium ion will also cancel out. So we are left with halide ion. What will be the charge on the halide ion? Which will be -1. And we'll have silver ion, which will have +1, and it gives silver halide AgX. So halide ion in aqueous, silver ion in aqueous gives silver halide in solid. So C is the right answer. So whenever you want to write an ionic equation, you will always cancel out the common ion in aqueous solution, and the ions which are left plus the solid, liquid, or a gas during a reaction, that you will also write. The energy level diagram of a reaction with an intermediate can be drawn. So here reactants are there, then intermediate is drawn, and then the product. Which arrow indicate the enthalpy change? So enthalpy change is basically the arrow which represent a reaction from reactant to a product. So when we check the options, so directly we draw from from reactant, the arrow which is from reactant to a product, that's called enthalpy change. So in this example is a enthalpy change. which graph correctly represent the Maxwell-Boltzmann distribution. So this is the fraction of the particle with a specific energy and the energy. Number one, the graph should not touch the x-axis. So C is totally wrong, because whenever there is a graph for a Maxwell and Boltzmann distribution, it should not touch the x-axis. When we check option D, the number of the fraction of the particle which have high energy that decrease and then suddenly increases. So that is also wrong, because it should continue to decrease, not increase. Then why B is wrong? Because they mention there are particles with there are zero particle with some energy. Like the graph, if there is no particle, they should have not have any energy. Here it is written zero particle will have also have some energy. So that's why B is wrong. So the correct description which shows that A is the right one. So most of the particles will have this energy. Few particles will have energy less than the average, and few of the particle will have energy more than average. So this is always the identical shape of a Maxwell-Boltzmann distribution graph. When we increase the temperature, what will happen? The peak will decrease and it will shift more towards right hand side. This is what happens if we increase the temperature. Using the Pauli electronegativity values in the table to answer the following question: which compound has a covalent bond with the greatest polarity? So if the elements have a greater difference in their electronegativity, they will have the highest polarity, because greater the difference in electronegativity, the bond will be likely to be more polar. So when we check the options, for water, H and O, so H is 2.1 and O is 3.5. So 3.5 minus 2.1, the difference, that is equals to 1.4. Then carbon and fluorine, CF, carbon is there and fluorine, so that will be 1.5. Then magnesium fluoride, magnesium is there 1.2, fluorine is there 4. But why magnesium fluoride cannot be the right answer? Because magnesium, whenever the electronegativity difference is more than 1.9, it means the bond will be ionic. And metal and non-metal, what kind of bond they will have? They will have ionic bond. But we want which compound has a covalent bond with greatest polarity. So these bonds will not be covalent, they will be ionic, because it is between metal and non-metal. So we are left with only two options, A and B. So we have to check between them only. So which is having the higher difference in the electronegativity? B is having the higher difference in electronegativity. That's why B will likely to be a polar covalent compound, or covalent compound with a greater ionic nature. This is called ionic nature of a covalent compound. Which is the most ionic? So the same idea, to know the most ionic, it should have a greater difference in the electronegativity. So when we check the options, the first one is lithium oxide. So lithium with oxygen, so 3.1, so 3.5 minus 1, so 2.5 will be there. Magnesium oxide, 1.2, and oxygen is 3. So it will be 2.3. Then aluminum fluoride, aluminum is 1.5, fluorine is 4. So when we subtract, it will be 2.5. And sodium fluoride 0.9, and fluorine is there 4, so it will be 3.1. So 3.1 means it is having the highest difference in electronegativity. So it means it will be highly or most ionic. Like the electron transfer will be complete. And the next question, table gives some data on fuels. Biodiesel is there, LPG, petrol, wood. Which fuel produce the smallest mass of carbon dioxide on combustion to generate 100 megajoules of energy? Look, if we produce 33 megajoules of energy, like produce, how much carbon dioxide is produced? 2.5. So we have to check the ratio for each. So for a biodiesel, when we check for biodiesel, so 33 is to 2.5. If you want to produce 100, then how much carbon dioxide will be produced? X. So cross multiply 100 into 2.5. So 100 into 2.5 divided by 33, that's equal to 7.5. So this will produce 7.57 kilogram of carbon dioxide. Then the second one, 24 is to 1.5. So 100 multiplied by 1.5 divided by 24, this will be 6.25. Then for petrol, only this factor will change. If 32 is producing 2.3, then 100 will be x. So 100 multiplied by 2.3 divided by 32, that's equal to 7.18. So petrol will produce 7.18. And for wood, if 10 is producing 0.9, so 100 will produce x. Cross multiply 100 into 0.9 divided by 10. So wood will produce the highest amount of carbon dioxide, which is 9 kilogram per liter. So the correct answer here, because the question is which produces the smallest mass of carbon dioxide. So LPG, liquid petroleum gas, produce the smallest amount of carbon dioxide. So B is the right answer. In question 17, which combustion of ethanol produce no change in the volume of a gas present at room temperature? So if the number of the moles of the gas are same, it means there will be no change in volume. So when we check the option, how many moles of gas only? We don't have to, so 3 moles of a gas and 2 moles of a gas. So there will be a change in volume, decrease in volume. 1 mole of a gas and 0 moles of a gas, so there will also change in volume. 2 moles of a gas, oxygen, and 2 moles of a carbon monoxide. So it means the number of the moles of gas are not changing. So it means C is the right answer. There will be no change in volume. Because number of moles of a gas of any gas, or 1 mole of any gas occupy 24. So if the number of moles of gas is not changing, it means the volume will not change. So this was from January 2017 unit